Hey folks, well, if you can't tell, I've been working, got all my cables laying here. Quick question, actually two questions on the ESP8266. Will it breadboard? Yes, it does fit on a breadboard. However, you only get one row of pins. So you'll have to jumper over if you need to do a more complex circuit. Second question on the 8266 is getting it to run under Arduino IDE. We will come back to that because that one's a little bit more involved. Additional question was, what is the best sensor kit? I only have one sensor kit and it just arrived yesterday. And the only reason is that I have a box of electronics and parts and components and all of that that's over in my storage, which I still not have gotten a chance to get over to and get. I will say that the one that I got, I'm actually very impressed with it. This was just grab it because it's got sensors in it. And they are breadboardable. In other words, they're simple. This is the Elegoo. I'm not sure how to pronounce it. E-L-E-G-O-O. Elegoo, I would think. I only opened the top of it and took a quick peek to see what was included, but you actually get a tactile keypad, which is going to come in handy. And then there's a whole list of different sensors in here. You have IRs, audios, trim caps. I'm not sure. This is an easy way to do it. This is a 37 sensor kit. Again, that's from Elegoo, E-L-E-G-O-O. This was around $30. I don't quite remember. Oh, wait. I know everybody's probably laughing at my tongs here, but when you have big fat fingers, this gives us a breakdown of what's in here. Yeah, so we have the water level, the power supply, joystick. Yep, it's an RTC. It's a real-time clock module. Flame detector, digital temperature. Ah, so it's a pyrometer. Okay. Switch, rotary encoder. That's what I was trying to think of earlier. Ah, magnetic spring. Ultrasonic sensor. Metal touch, linear hall, small sound. Tracking, motion tracking maybe? Motion avoidance. Big sound. 2-color LED, IR, photoresistor, which we got. Single button with a laser emitter. Interesting. Shock mount tilt switch. LED. Surface mount RGB LED. Tap module. Okay. Photo interrupter. Temp and humidity. So I got that right. Active buzzer, passive buzzer. Very nice. This should give us enough to keep busy for a while. But yeah, so the question was on the sensor kits. What's the better one? I can't say that this is better than any other, but it does appear to be quite a complete set. I don't like the way that... Oh, because that was not on there. I got really excited about the joystick, so we'll come back to that one at a time down the road. Maybe we can just do projects out of this kit. That might be an interesting one for everybody. Something dawned on me talking about the breakout board for the ESP, the 8266, sorry. I have an ESP32 with a breakout board. I will dig around and find that and put it in the next RasPi video. Okay, so staying on, excuse me. Staying on the 8266 topic, let's switch over to the Raspberry Pi 4. Okay, on getting the 8266 to work with Arduino IDE. This is only fresh in my head because I just did this, so that was good timing. It's set up a new machine. You know, when I set up this RasPi 4, you can see I loaded the blink sketch to the 8266 to make sure that the connection worked. So the very first thing you need to do, because what will happen is you're going to come over, you're going to look for your board, and your board will most likely not be listed in the default boards. Why am I not showing up here? What is... Alright, hold on just a minute. Let's switch you back over here. Let me close my... Okay, now it looks like it refreshed. That's bizarre. Yep, it sure did. Okay. I'm not sure what happened there. So on the Arduino IDE, when you first install it or first set it up, you may have a problem finding your board as you go down through the list. Again, that's under Tools, and then Board, you choose your board type. So it's very common that initially it will not have the board that you need. So in this case, it does because I installed it. Well, it's straightforward to do. You go to File, Preferences, and you're going to have to paste in this URL. So I will copy and paste this into the description for this episode. You just paste that in and then hit OK. Once you've done that, you'll come over to Tools. Makes me wonder, did they move it or did I just not remember it? Anyway, and once you get it installed, so I'm waiting on it to download the platform index. Once you've installed it under Preferences, then you have to go to the Boards Manager, find it, and then select it to install it. In this case, I'm running 2.71, which is the current version, but you can go back multiple versions backwards to download for compatibility if you find that there's something not working correctly. What I can do, make sure I have, yep, I do have the correct cable. So just to show you that that is working. So already the board has run, and it's just running the blink sketch, which is very straightforward. As we switch over here, so you can see we're bringing the pin high for 1 second, bringing the pin low for 1 second, then we go back up to the loop, do it again. So in this case I will change this around, and we'll do it the opposite way for 5 seconds just to show you that the board is working. Let me bring this bottom up so you can see what's going on. So just so you see, I set this to 5 seconds. So you can see the output as we transfer this program over. So now I'm pushing that sketch. We're still compiling the sketch. In just a minute here, you should see it pop up. But while it's doing that, let me just bring you over, and I'm going to show you we're blinking on, off. So 1 second per cycle. Once this finishes compiling and then uploads, we're now writing to the chip. Hard reset. Waiting on the The reset did it not? Oh, it didn't take the, that was the first sketch. Okay, so we're going to push the second sketch with the 5-second delay. I was like, why is it only going for a few seconds? Okay. Well, you saw the process. So now we're at 33%, 41%, 50%. So I will bring you over to the camera. Once the sketch is completed, which it should now be complete. So now we're getting 5 seconds low, 1 second high, 5 seconds low, 4, 5, so now you can see we changed the time. Next question I had was on the Arduino. Should they buy the Uno or the Mega? It just depends on what you're going to do. The Mega is full to this point, so the board is the full width of this rectangle. The Mega gives you more pins, it gives you more memory. For basic stuff, I find the Uno works just fine. Like I showed you guys a while back, we can actually pull this chip out and use it on another board or in our own build. You can buy them with the bootloaders, as I showed you before. All of these that I bought have the bootloader installed. You cannot buy just an 8266 and expect it to work. It needs to have the bootloader. Yes, you can install a bootloader. Well beyond the scope of what we're doing right now. I'm trying to stay even with where you guys are at, process-wise. Skill level, I guess we could say, without being insulting, because I still lack a lot of skills. Our camera. Back to, and we'll close out Arduino. We don't need to save that. I did migrate the camera to the RasPi 4. Oops. Okay, so now we're over on the RasPi 4 again. What I did is I positioned the camera with a view of the ESP8266. Once that photo is taken, I will show you. Just to show you the view that we're actually dealing with right now. I will post the screen up on the website. I don't want it to get messed up on YouTube, because I've noticed where sometimes it mangles code. So I will post this up on the website. It's stfuandfish.com. Basically, it's pretty simple. We're shooting a one-day video, so we have to import the time, import Pi camera. Again, in this case, it's lowercase. It's not, we're all lowercase here. Don't mix case. Unless we specifically point it out, or a piece of code specifically points it out, leave things at the case that you see them at. Don't just capitalize a word for the hell of it. We're actually going to take stills for one day. 60 frames per hour, so 1 frame per minute. So we will have 1,440 frames from a 24-hour day. But we're shooting down at 24 frames per hour. Either way, so the frame, again, Pi camera, it's Pi camera. Sleep for 2 seconds. We're going to number our frames. This is really straightforward. It's very well commented. This is a generic piece of code I found that's quick and dirty, and it does work very well. I tend to save snippets of code. You'll see a lot of programmers do this, so that we can always refer back to it and say, well, this worked, in this environment, so we'll go back and reuse this code. That's the wonderful thing of programming, the ability to reuse code. Pi desktop. Actually, let's do this. Let me come up here. I'm going to create a folder. We're going to call it Timelapse. just to show you that folder is empty. I'll bring it back over here. We're going to go back. Whoa, I didn't want to reopen it. Good, it got smart and left the same one open. All right, so we are ready to run. Again, the picture is of the EP6266 on the breadboard. This is our first image. So I'm going to come back over and just start the script. And make sure that we... Oh, crap. Stop. Let's get rid of frame 0. Did anybody catch what I did or forgot to do? I didn't come back over here and change the folder to our new folder, the Timelapse folder. Make sure whenever you're looking or using somebody else's code or code that you have not written, that because you see it defined here, always check the rest of the code to make sure. And there we go again. All right. So we'll go ahead and run our script as is. I'm not going to close out the editor, so you can see there's our first frame to show you that it is changing. Whoop. I'm adding something to the frame for the next shot. We're still waiting on the frame. While I'm thinking of it, another thing, think about the size of your images and the total capacity of your storage. If you're only using a micro SD of a couple gig, so at 1.3 meg per picture, we're going to take 720, well actually 24 times 12 photos. So we're going to use up for 24 times, yeah, just say about 2 gig in photos, 1.2 gig in photos. So you need to make sure that you have the available storage space on the micro SD. If not, put it to add a USB thumb drive. You can do that. Most of them are fast enough nowadays to write to. And then just modify your code to store in that thumb drive. So just to show you that the change, you know, that we are actually taking stills. There's our first photo. Oops, there it is. Here's our next photo with our little minion. I will turn the minion 90 degrees so that in the next photo, he's turned 90 degrees. We'll turn him again. So there you go. There's our script running. We will switch back just to show you what I did here on the webcam. So the camera is here pointing down at the ESP, and all I did was rotate him around. It's fairly straightforward. All right, so our next trip on this will be for me to actually get the camera mounted. Instead of using my third hand to hold it in place, I need to mount it on something. Sadly, what I thought might work, and I don't remember if I pointed this out in the video or not, we're talking about our slot on here that's on the Neo case does not fit. The footprint of this board is too wide. Put my lens cap back on. I'm actually checking the temperature of the case. Something felt really warm here. Is that the camera? No. There's a little bit of heat, but it's not too bad. It's not bad at all. All right, so that will be my next project. For the next video, we will get the camera mounted onto some type of a platform in the correct rotation, and we'll stick it out the window and do a 24-hour time lapse. Be good, be well, we'll see you tomorrow. You know the drill.